Hello again. I'm continuing with the clinical chemistry analyzer. So today I will do some definitions and a little bit of history of three technologies used by analyzing chemistry and immunology: ISE, photometric test, and ECL. So if I start with the ISE technology, it's used to determine ion concentration of three ions: sodium, potassium, and chloride. The ISE model has either one or two ISE unit. The ISE unit performs indirect measurement of EMF, electromotive force, in millivolts between ion electrode, selective electrode, and reference electrode. The EMF value of each sample are converted into millimoles value by calculation algorithm that uses EMF data together with from 2-point calibration with the 2-point two primary calibrators. So that's the definition of it. And if I talk about about the history of ISE, the development of ion selective sensor began more than 100 years ago when, at the beginning of the 20th century, the Kramer invented the glass electrode, which for quite a while people used it for a while. It was successful. And then Haber and Kelemenowski were also doing the same thing. Extremely important of potentiometry was the year 1966 when Frent and Rose announced their pioneering discovery of fluoride ion selective electrode. However, that was little bit of improvement, but however, a breakthrough in the field came in 1971 when Fraser and Cartel invented the fast solid contact ion selective electrode, which they call it coated wire electrode. It was the first ion selective electrode in which there was no internal solution. This completely made a new revolution on the field and opening a way to a number of new construction of possibilities. People were doing experiment from left to right. Up to now, it's continuing, and the latest I can get the reference is 2022. The second definition and the history will be photometric technology uses photometer lamp to beam a light through the sample. A detector uses the absorbance of the light. From the absorbance, the instrument calculates concentration of the sample. I'm using an example as a cobas C, and it's true on both chemistry and immunology as well. So if I this is I explained it on earlier videos. I don't have to go through again. And this is a schematic of how the clinical chemistry analyzer works. The light is separated. The separator light is shined to the sample. Detector collects data and it sends it to the computer. And this is also how the machine works mathematically, Beer's law. So from the Beer's law up to the machine you use as a chemical analyzer. And this is in a very simplified example. And I explained other previous videos on this. Okay, I'm stuck here. Okay. Okay, if I talk about the history of a clinical analyzer, I cannot finish it, all of it, but I will touch on it few aspects on. So the first individual who invented was Leonard Sachs in 1957. He was the first one. He he developed something called segmented flow analysis. Um, the system which was initially called continuous flow analysis. Sometimes some people call it continuous flow analysis. Um, uh, it's In this system, the sample is pumped continually, occurring a cleavage by air bubbles, and then immediately adding the reagent. Thus, the mixing and subsequently reaction occur while the sample and reagent segments flow towards the detector. So they mix it, and it goes to the detector, and the detects. After that, there was another gentleman who introduced another. It was two gentlemen. Risky and Hansen introduced concept of analysis system influx, which uh, became known as the abbreviation FIA. And after that, they changed. They made little bit improvement to monosegmented flow analysis. And each one, if you want to know, there is a book for this, and there is a book for this, and there is a book for this. And so this is the one I was talking about. So this one made a little bit improvement of this FIA, and this is the guy who introduced it. Is they this another is another invention. They added a little bit up to we get to the flow batch analysis. This is currently a little bit more improved what we use today. So they divide what is called so they divide clinical chemistry analyzer into three: automatic, discrete, robotic, and automatic. The discrete is the flow batch analysis, is the same, discrete or a batch. So, for example, if I give you an example of equipment, 502 of a huge company, Cobas C502, is a fully automated discrete clinical chemistry analyzer. So before we get to the flow of batch, it was manual. So that's why it's automated, and it's also discrete or batches. So the history behind it is this gentleman called Honorato proposed automated system to enable execution of titration by using Fibonacci method. Fibonacci method means is a method by which the calculation is made. The sequence numbers are the sum of preceding number. For example, 0, there is no numbers in front of 0. 1, there is no number, so the 1 stays 1. But the third is going to be 1 plus 0 is still 1. But 1 plus 2 is 3. So on. And 2 plus 3 is 5. That's the Fibonacci method. And that's what this guy Hornot proposed, and that's what we get up to right now. That's what we using right now. I cannot take too long to explain that, but you can look. Each one has a book, and you can buy it, and you can Google it, or you can get a book that will explain how the theory came up, and where we are, how we get to where we are. All right, this is during the manual time. This is the this one, that one. Um, all right, let me go to the last and third one. So the chemiluminescence technology is used in immunology. Basically, it's used based on reactions of two things: ruthenium, which is a metal, and TBA, which is very reactive. And photomultiplier measures the emission of a light. So, so I talked about it. It's two. This is very reactive metals. You can look at the periodic table and refresh your basic chemistry. This is metals and root using ruthenium. Cobas uses ruthenium. So in a basic reaction, you know how the things are go by step. First is incubation of two highly specific antibodies to the target antigen are used first. The first antigen is labeled with biotin, the second one with ruthenium. Then they form the two, and they target the antigen and they make a sandwich. And then microbead coated with streptavidin is applied to the solution to form strong with a biotin that reacts with a biotin. And then a solution is aspirated into the measuring cells with a magnetic field. So measuring cells has a magnetic field, and then it's washed. So that's the reaction. And second, how we generate the light. So after washing, TBA is introduced to the solution to provide the lighting. And after we use the TBA, we use a little bit of voltage, to excite. The TBA radical serves as a reactant enabling ruthenium to return to the stable base state, with the release of light. So when the ruthenium returns to base, it releases a light, and that's how we get to the light. And I don't have time. YouTube has a limited time, so let me go to the history a little bit on schematic. Don't worry, all this I will explain later on other videos. First, in 1920s, these reaction emitting lights were everybody was seeing it, but first experience was done in 1964. Then theory was made, then transient happened, then they introduced it to magnetic field, then ruthenium, and so on. I will recommend you, in order to understand the flow of time, buy this book on Amazon. It will explain everything step by step, and where the experiment, and also data that can be seen, how they derived, what they derived. And that's it for me today. Thank you.